Hey, welcome everyone. We're going to go ahead and get started. Welcome to the first Salt meetup of the Salt Lake City group for 2018. And I'm Kevin Koger. I'm with SaltStack, and we're thrilled that you're all here, whether you're here in the room with us or joining virtually with the live stream. Welcome. Now, the plan is today to take about an hour. And our topic, as you well know, is identifying and remediating vulnerabilities, focusing on the hot topic of the day, Spectre Meltdown. And our presenters are going to be the well-known Krister Edwards from Adobe, computer scientist extraordinaire. Joining Krister in presenting is, your name's not Christopher, I know that. Krister in presenting is Mark Hopper, a solutions consultant from SaltStack. And again, the plan is to take about an hour. Housekeeping, if you have any questions, if you're in the room, just raise your hand, stand up. I'll have this mic. I'll be sitting here at the front table. The reason we want you to have a mic, you can probably hear each other in the room, but if you don't have the mic, the people on the live cast won't be able to hear you. So just raise your hand real quick. I'll run to you, get your questions answered. And with the live cast, if you want to ask questions, just message those in through the meetup, or you can email me at kkoger that's KKOGER at saltstack.com, and I won't know the answer, but I can at least get to Krister and to Mark and get your questions answered. So lastly, have some pizza if you don't already. If you do, have some more. And if you're on the live stream, enjoy your latte grande or whatever might be your beverage or lunch of choice. And with that, I believe I'll turn it to Krister.
Can you hear me now? Okay. I'm going to talk a little bit today. I'm going to let Mark do the bulk of the time, but we had discussed someone needs to make sure we all understand what these vulnerabilities are and basically kind of how they work and how we look for them. So I'm going to cover that part, and then he'll talk about additional detection and remediation using SALT in a more general purpose use case. So to start out, if you just leave after this, that's about it. This is why we can't have nice things. Everything's broken now. I don't know how many of you saw this, or if you can read this from there, but XKCD did a comic about this. It's basically explaining with the speculative execution in Linux, it's like we send two trains down, the train dilemma, just quantum style, and then when we don't need one, it'll just disappear. It's fine. Well, they don't actually disappear, and they can drive through walls, so that's a problem. So as they mentioned in the bottom middle comic, we just suck at computers. So if everyone can just accept that, let's just try to suck less. But I think we kind of suck at computers. So basically the problem here is we made computers idiot-proof and really fast, but then we just built better idiots. Basically, we fixed, and I put this in quotes, we fixed this problem. I don't really consider it a fix. It's more like a workaround, I don't know. But essentially, we separate user space and kernel space completely. We can no longer trust user space to not spy on and do malicious things to kernel space. So we can't have both. Let's see. Yeah. So basically, it comes down to this. Before Meltdown and Spectre, I keep doing that. Computers could be secure and fast. Now you can pick one. So depends on your use case. I mean, the fixes for Meltdown and Spectre, at least in Linux, are designed to be able to be disabled because you can be fast or you can be secure. And some people can't afford to slow down, so they have a choice to just turn it back off. So essentially, we have to pick one. I don't want to just pick one. Linus is also not pleased about this. I don't know if you guys have followed any of the stuff he's said, but he's been fairly angry and vocal. Because this is a problem down in the hardware, they're very upset. The fixes are not great, and this is a problem. So I wanted to present briefly, just to give you an idea of the feeling and the kind of the upset that even the core maintainers of the kernel have. These are technically accurate and suggested names for these patches. The first one is kernel page table isolation, KPTI. Okay, this is the one we went with. That's fine. Everything's good. Another one was this. That acronym is a little bit different. There's also this one, which I won't, but that was a legit submitted patch name because they are mad about this and really upset with Intel and, okay? So, I included that link at the top because if you want to go see I'll show you the source where this is in there. I'm not making this up. So again, to fix this issue, we basically take kernel space and user space, and they don't get to talk, they're not friends anymore. We can't have nice things. So the way that I want to kind of help you think about this is, let's just think about like a volleyball court. We're playing volleyball. One side of the court is user space. We have our team, and the other side is the kernel space. And as we compute, we kind of volley the ball back and forth, right? We do some stuff and we hand it back to the kernel, and the kernel has to do some stuff and it hands it back to us. But the kernel is supposed to have access to things that we don't. But now that we have trains that can drive through walls and apparently do whatever they want, that is not tenable anymore. So basically the solution is, at least with the patches that I've seen, is if there is activity and if the ball is active on the user side of the net, clear the court on the other side. The kernel cannot be on the court while users are using stuff. As soon as the ball crosses the net, then the kernel can run in from the sidelines and try to react to it, but that is not an efficient way to play volleyball. It's not an efficient way to compute, right? But if there's nobody on the other side of the court, there is no information to deduce. There's no information to steal if there is just no information there. So essentially the fix is, we tell the computer that if there's activity on the user side, the kernel nothing's going on, can't do it, which will slow us down significantly, especially things with high I/O, databases, stuff like that. Postgres and Oracle and stuff, I'm glad I'm not like a DBA with these problems. Or you can disable the fix and let them just play volleyball, but you're not secure anymore. I know that's kind of a generalization and there's some simplification to it, but if we think about it that way, I think that's kind of what it boils down to. Now, so now that we kind of understand what the problem is, we need to just know, we need to detect it. We need to know where it's a problem. We can't fix it if we don't know it's broken. So, everything I know, I learned from G.I. Joe. Knowing is half the battle. If I don't know what's broken, I don't know what to fix, right? So one of the things that we focus on, and particularly for those that are familiar with Hubble that we develop here, we need to know where the problems are so we can make intelligent decisions about who needs to be patched, maybe who can afford not to be a database or something, right? It's because it's built that way, we could do that. If we can know faster and we can react faster, then we can move faster and adapt to these these evolving security targets. So I want to show you something. Again, if you're familiar with Hubble that we developed here, the security and compliance automation tool, the day that Meltdown and Spectre were announced, I read a little bit about it, kind of got some idea of how it works and how the kernel fixes it and so on. And so I thought, you know what? I originally thought of how Hubble should work. I want to demonstrate that Hubble is super flexible and adaptable to moving targets and evolving security issues. So I just sat down that afternoon and started writing data for Hubble to go find it. So I want to show you what this looks like. No, you don't need to see my Jira or my email. Not that one, not that one. Should have had that queued up. There it is. Okay. So this is what we're working on internally to look for Meltdown and Spectre. Now, this is just YAML data. It's not hard. I didn't have to sit down and write a bunch of C code and be elite programmer to do this. I just used this basic syntax that we have in Hubble to say, look, I want to use your grep module to go blacklist any package, or let's see, not a package in this one. I want you to grep in here, and if you find a 0, then we fail. If you want to grep in here and look for this value, we pass or we fail. This is just different places to look for the telltale signs of either the mitigation or the vulnerability. So you see we have support here for CentOS and Red Hat and anything on Amazon and Debian, Ubuntu, so on and so on. But this is just, the whole thing is 191 lines of YAML, including comments. And as far as I'm aware, this looks for every way we could think of to look for, is the mitigation in place? Has the mitigation been disabled? And are our machines still vulnerable? Have they been patched or not? It's just a simple syntax. It just reads this in and goes and looks for stuff. The idea behind Hubble and being able to gather this data quickly and efficiently is I'm just going to use the native system tools to ask the system, is it configured in an appropriate way? Or has its checks been disabled, or so on and so on. So this one's a little bit more complex, but we're going to look in the proc command line and look for this ugly regular expression, right? But the computer can tell us, well, yeah, the kernel's technically patched, but somebody told me to do PTI off, which is page table isolation, off, and they disabled the fix. So we look for disables, we look for where it's been patched, and we have support for a whole wide range of distributions. So again, I wanted to show this because Hubble is really, really adaptable and flexible. By the end of the day, when it was announced, we were ready to start looking for it. We had ways to detect it, and we could start gathering data and start making decisions on that data. So with that, I think that's a general overview of what the problem is, how the problem can be resolved or optionally disabled, and tools like Hubble that you can use to start looking for these really quickly. I think with that, I'm going to hand it over to Mark, and he'll have some more demos and some SALT-specific things, I think, on looking for the same stuff and also hopefully trying to patch some of it.
All right, can you guys hear me? I had deep pockets and I couldn't grab this thing. Well, I want to give Krister, a big thank you in presenting this information. He is, we call him. He's welcome in our office at any time, and he comes in and walks in, and he's been extremely helpful as we prepared for this meetup in disseminating information and making sure that this goes off smoothly. So I want to give him a big thank you. We're really, from a SaltStack perspective, the message that we want to get across is not necessarily specific to Spectre and Meltdown, although we're using that as the vehicle to have this conversation. But we're talking more about what we want to get across is the ability that you guys can use Salt to not only detect if you're vulnerable to security vulnerabilities out there, but also talk, have some conversation about the remediation of such. And today we're using Spectre and Meltdown as this the vehicle to have this conversation. Now, by show of hands, I recognize a lot of you guys. Is there anybody that saw, an email blast or saw our meetup thing? Someone 40 that. Is anybody not familiar with Salt? Please feel free to raise your hand. So, okay, all right. That's good. I just do want to just reiterate this one slide on generic. Sometimes we get people who are not up to speed on Salt, but essentially Salt has 4 tenets or foundations, and they are remote execution, configuration management, this idea of an event-driven infrastructure, and then obviously cloud management is our 4th, where we can integrate with the cloud. But I'm not going to go too much into that from that perspective. I want to delve directly into vulnerability scanning, talk a little bit generically, and then we'll delve into some of the things that Salt can do outside of, to help you guys detect vulnerabilities that are very specific and very intricate, like the Spectre, like what we're dealing with Spectre and Meltdown. We do have, so here on the screen, and unfortunately, the output, I thought it may show a little bit bigger on the screen than it did, but on my screen, I had zoomed into my terminal session as big as I can to create this screenshot. But what we have here is, how many of you are using Windows in your environment? All right, okay. Now raise your hand high so I can see it. Okay, we've got some Windows users. So here's a shout out to the Windows guys, right? Sometimes you get lost in these things because, but we do have the ability to, and so does Hubble, by the way, go out and scan vulnerabilities in Windows. And so we have what we call this update agent module. And what I did, and you really can't see it, but I specifically ran this module against my environment, looking for critical updates that are security related. And so we can get extremely granular on this, and it came up that there was in December of 2017, there's kind of a roll-up security update that it's showing that this machine is vulnerable for. So we can go in and scan for those vulnerabilities. So, Windows, as far as Spectre is concerned, you update it and you check for that. It's a lot. The nuances don't seem to be there from the Linux that they exist on the Linux side, as far as my research. And the stuff was changing as I was researching for this. We're having vendors pull their patches because of the performance hit that Chris are talking. Intel released a microcode update, and it really and then they pulled it, right? So, but we can get granular on that. Now we do check vulnerabilities a little bit different on the Linux side. This one's a little easier to read. But we have something very similar in the fact that we have our package module where you can actually look at our upgrades available in the versions. So here I have 2 different switches that you can see. First is is there an upgrade available for the kernel? Spectre Meltdown is essentially a kernel patch update. And so you can see, yes, in this case, Minion 1 has been patched, so there's no upgrade available because it's the latest version of CentOS. This is a CentOS box. And then the other show the upgrade. So then I wanted to go, okay, what is the upgrade that are available? What's the latest version? And it dictates that latest version. So there's a lot of tools, and this would apply to any package, not just the kernel, but I'm using that as the piece for the kernel from that perspective. Do we have a mic, Kevin? Is there any questions just on before I jump into some of the specifics around Spectre Meltdown and how you can look at things from a SALT perspective? Any questions out there? Is anybody monitoring the online? Because I have no way to. Okay, all right. So there are, in addition to, there are ways to go. Let's look at what kind of a recap of what Christopher talked about. With Spectre, there are basically 3 variants. There's 2 variants of there's Spectre 1, Spectre 2, and then there's Meltdown. They're all variants of the same problem. And that's this problem that people were being able to determine what was happening in kernel space from user space. And so, going back to Christopher's volleyball analogy, ultimately that's a problem. So there's various aspects that make a machine vulnerable out there. So there's various ways to determine this if SALT. So in SALT, if you want to, okay, I know about this Spectre Meltdown thing. I want to just go look at, if I look at the nodes that I have, am I vulnerable? So we can go and first thing we can do is we can go get what versions of the kernel am I running, and that will, well, what versions of the kernel are out there in my environment. So if I run this, so I want to point out that I'm running a live demo, and I did not have time this morning to sacrifice to the demo gods. So bear with me if this kind of goes south. But so we have the ability to go tell what version of the kernel is installed. Now, in preparation for this, I ran out of time, and I had before is I actually upgraded the kernel on a couple machines, and then I ended up, well, let me blow away my machines, and so you can't see the output I'd like. But can anybody tell me, and I know there's a lot of Linux guys in the room, if I update the kernel on my Linux box, what happens to the old kernel? We're going to want to go to the mic, but I want to, what's the problem of just running, yum upgrade kernel or kernel version? Does anybody tell me what the problem may be with that? Yeah, we have to use the microphone. We have a pretty good online audience.
All it does is install the new kernel. It doesn't actually start running with it. You have to reboot the machine in order to run with the kernel.
Great. So part of the problem is you have to reboot the box. Now, if you reboot the box, is that machine still vulnerable? Anybody want to answer that? Try to stem him over there. He runs fast, so it's the only time I really get order my sales guy around.
Usually the old kernel is still available to boot.
Yes.
If you want to boot to the old kernel.
Yes. So when you run this, if you had multiple versions of the kernel, and I think by default it stores 3, you would see all the versions of the kernel there. So this would allow you, to determine, okay, these machines could potentially be vulnerable. So in this case, Minion 1 is not vulnerable because it's got the latest kernel, but Minions 2 and 3 are vulnerable. But in my previous example, you actually saw 2 versions of the kernel, so it's a possibility that it could be vulnerable. So that we can go out and search that, and I've got a tool that is actually, I've been at Salt for 3 years and I didn't even know this existed, so it's kind of cool. I'll show you that here in a minute. The next piece that makes this extremely difficult is the ability, well, let me back up a little bit. There's another way, another check you can do to determine possible vulnerability, and that is when you install the new kernel, it actually installs some files. In this case, and this goes to the 3 variants, but there's a file in this directory which is sys kernel debug x86, and there's a PTI enabled. There's that's for the page isolation table. There's the IBRS _ enabled file. That's for the indirect branch restricted speculation. And then there's this one, I think, is the prediction. But there's 3 files that relate to the 3 variants, and it has, those variants have to do with if I ping this information from the kernel, I can speculate what's there, and then there's different variations of based on what it's not doing, I can tell what's there, and that's what these files. So you can go out and determine, okay, these machines are patched because A, the kernel's there, and B, these files exist. So again, the Krister's Hubble profile does a detection for this, and you can actually look at that. But there's ways to do that with Salt as well. We're going to go in and detect, do these files exist? Now, where things get really interesting is with the ability to, in Linux, to turn this off. And so another way you want to check to, and this check, because I haven't turned it off, I actually didn't know what files in my, where I needed to put in my grub config to turn this off. I didn't know that data, but I can go out, so it's actually saying that this doesn't exist, this pattern. But Salt, you can go out and look at a configuration file, in this case, the grub configuration loader, and say, are there any entries in my bootloader to turn off the actual code that fixes this this table where we're clearing the volleyball court, right? So we can go in and use Salt modules to go grep for certain aspects of in this case Spectre. Now that would work with any other kind of complex vulnerability. So we can look for the update. Is it installed? Are there, not only is the package version right, but are the files that need to be in place for that fix to work, are they there? And in this case, has anybody in the bootloader disabled that? So you can check for potential vulnerabilities as well. And then the last piece is very similar to this, where you're actually looking for, instead of in the grub config, you're looking in the proc command line that tells you what basically was this no PTI switch started from the, so you can say, yeah, the kernel was loaded, but it's the correct kernel's loaded, but it's been disabled. So again, if I run that, we're going to get failures because I didn't put the no PTI in my config file. But so these are all ways that Salt can detect that in real time. Now, interestingly, there's a tool that has anybody leveraged the survey tool with Salt? I've got some developers here from SaltStack. So you've run everything, Trevor. You've run everything. I'm seeing a nod over here as well. These guys, you know, they like, I think they dug salt out of the Morton salt plant before any of us ever got involved in salt. But there's this tool I didn't know about, and that's one reason I love my job. But we have this survey tool, and what I'm going to do is I'm going to look at a difference across my entire group of machines of what version of the kernel I have. And so this is another tool you can use to go out and look at, am I vulnerable? So I'm going to run this survey.diff tool, and you'll notice that it pools my machines together. So this is pretty cool, not only just from a vulnerability, but what version of the application am I running, or any configuration. But you can see that it goes out, it gathers that information, and then it pools it together. So it's the survey module. It's actually a survey runner, and then you just pass it what you're looking for. In this case, I passed it the module from the package version module. So that's just another tool to be able to go detect vulnerabilities that are complex, like Spectre Meltdown. Typically, most of your vulnerabilities, whether it's something like, if we go back in the Wayback Machine, Heartbleed, Shell Shock, or on the Windows side, if you're looking at WannaCry, typically you're going to be able to get by with just looking at the either the package module on Linux or the Windows Update module on Windows. But what we're seeing now is very interesting. And as I read to research this, we've kind of morphed. I used to work in the security space, and we've morphed from just guys, oh, look at what I can do, to actual criminals extracting data like credit card information exploits, particularly in application like browser type vulnerabilities OS. But now we're seeing some very, very sophisticated attacks on the hardware level as well. So, but Salt can help gather that information. This tool right here can help gather the information. You can output this to a file or whatever on your larger environments from that perspective. So from there. Now, I do want to jump in and show you some other things from Salt perspective, but before I do, any questions out there? Okay. All right. All right. I don't know how to look at this.
You have to modify the WSUS module.
No. So the question is, you have to modify the WSUS module. So our Windows module for update, I'm assuming that's talking about WSUS for Windows updating. Our module is called Win_WA. It stands for the Windows Update Agent. Now, the Windows Update Agent module, what it does is it'll just tell the Windows box to go to whatever source that Windows machine is configured to. So if it's configured to go to a WSUS server to get its updates, it will go to that local WSUS server. That's completely independent of Salt. Or it'll go, that Windows Update Agent, if it's configured to go directly to the internet, will go directly to Microsoft and pull that down. So that's how our update agent works. So we're telling the update agent to go look for updates, and that's going to go in real time if it's to either the WSUS or to the internet. We did not need to update that module to detect Spectre Meltdown vulnerability. That's coming from Windows from that perspective. Now, Microsoft did pull some updates out of their system due to Spectre Meltdown that they and quickly put out a vulnerable patch, but then they pulled it. Subsequently, I haven't determined if they've put that back in there, but we didn't have to modify anything. Other question on this? There are a couple of questions online.
Yeah, there's one more. Can you show the command used for the survey tool?
Yes. So let me see if I can make this bigger. So that's as big as I can make it, but it's salt-run survey.diff, and then I'm giving it a target, in this case, a globular expression for anything that starts with min. I have 3 machines called minion 1, 2, 3. And then I put the module function and any arguments that I want that module function to run. So what happens is the runner on the master will run that survey runner, and then it will actually run that module, that command on the actual minions and show me the differences, come back and it'll pool those differences together. So hopefully you can see that online. But just look go if you want to Google survey runner for SaltStack, it'll show that up. But it just pools them all together. Pretty cool tool that, again, I didn't know existed. Great questions. Any questions locally? All right. So the last thing I want to show is we do have in SaltStack Enterprise, which is our commercial offering, just to give a shameless plug for our engineers from SaltStack that showed up today. We just released 2 days ago our version 5.3. So brand new release of SaltStack Enterprise. But SaltStack Enterprise, we've actually baked Hubble into SaltStack Enterprise. So it's kind of turnkey. And so I was able to leverage the profile that Krister showed within SaltStack Enterprise. Just kind of want to show you. So here I've created a job that goes out, and it'll go out and audit all my machines. The output is going to be similar to what we already saw, particularly in that diff tool, but it's visual, it's in a graphical format. So if I go and I did my initial run of this audit, and see that I've failed, and so you can see on the actual kernel update, I've got some machines that have failed from there. So I can see the groupings of machines that failed my audit. These are vulnerable to Spectre, and you can see that now. What I can do is I can group these machines, and then the fix for this is difficult. I initially set out to hopefully create a state file that I could share with you and show you this, but right now, things are such in flux with the various vendors pulling their patches, and then the various, particularly on Linux, various aspects of, are there multiple kernels? Are you vulnerable there? Do I need to delete old kernels? Do I need to, are there entries in my grub config that would allow someone to reboot the box and turn this fix off? There's a lot of factors, but ultimately we can create, you can create a remediation state file based on what your needs are, based on the operating, and create that. But how would we remediate that from this perspective is I can go ahead and then choose my machines that are vulnerable, and then choose right from here, run my Spectre remediation job, and then I can go ahead and run this directly against those boxes from that perspective. And then once you do that, you can rerun the audit through SaltStack Enterprise. And let me just show you what that may look like. If I go here, you can see that now I have all the different vulnerabilities that we're checking for, the different CVEs, the meltdown, those 3 variant pieces there of are these things turned off? And you can see that I've passed those from a vulnerability. So the interesting thing you can do and so for those that are in Salt Open, there's tools that you guys can use. There's Hubble that runs with Salt, and then there's tools within Salt itself that you can mix with maybe high state routines or ad hoc remote execution calls to go determine vulnerability. But also we have the ability to from a graphical look at that and see graphically in more of a report, and then do remediation directly from those reports with SaltStack Enterprise. So now when we get to one thing, I always try to plug event-driven infrastructure anytime I talk about Salt, because really the coolness of Salt is the ability to react in real time and automation and do things based on what's happening in real time. And so with vulnerability scanning, whether it's CIS policies or CVE scans or security updates on Windows, with Salt, you can schedule those to run on a periodic basis. And based on the returns, you can automatically, if you wanted, to remediate those in an automated way, whether that's send an email to the front level NOC guy to go open SaltStack Enterprise and push a button, or whether we orchestrate the patch and the reboots that are necessary. Mentioned we need a reboot on a kernel update, and that's where Salt's automation engine can come into play. So with that, I do want to open it up. We have a few minutes. I want to open it up to questions. Trevor.
I noticed that with the enterprise version that there is a remediation step for Spectre and the meltdown vulnerabilities. Is it still HubbleStack's position that they're not providing remediation? They're expecting your systems engineers and your administration staff to follow through with that. And do you have any time to talk about that?
Yeah, there's 2 pieces to that question. And my understanding from Krister is their philosophy is they're not HubbleStack. The HubbleStack project is not going to be providing remediation steps. And the other part of that is that's a job that I, as the Salt admin, created in Enterprise for my environment. That is not something that Spectre remediation is not something that I don't want to give the impression that we have that built in out of the box today in SaltStack Enterprise. Now, the sales guy, maybe he wanted me to say, yeah, because then people would flock to us. But that is a job, I just want to clear that. That's a job I created for that. Now, that being said, with our implementation of Hubble, we are on our roadmap is for us to provide sample remediation jobs that a customer could possibly use in their environment and tailor to their environment from that perspective. While right now we do not ship any of those remediations with SaltStack Enterprise, that is on our roadmap to do in the future as part of what we offer from a security type perspective, in addition to the Hubble. So, and our implementation of Hubble is current on Hubble at the time of the release of that version of the product. So right now, our version of Hubble is this current version because we released 2 days ago. Our next release isn't slated till June. So as Hubble evolves, every release we will bring down the latest Hubble as part of just being a feature of SaltStack Enterprise. But great question. Any other questions?
This is Ryan with Adobe. I have a question about Spectre Variant 2. That vulnerability is difficult to patch against. You can change your compiler to use return trampolines, or you can deploy microcode and firmware updates. Basically the two ways that are available. This is the patch that Intel released, and it caused stability issues, and they pulled it back. And now they have a beta patch out that's supposed to fix it. They say they've hopefully solved it. Hopefully we'll see production-ready patches soon. So as we have teams that are looking at hardware-level patches, they need to deploy firmware. They need to get subcomponents of systems updated. Have you guys looked at the workflow for that in Salt, and what's involved in managing system firmware from that perspective?
So we do have, let's see if I can pull it up because I don't remember the command offhand. We do have the ability to look at BIOS level. So Salt, I'm going on the fly just to try to answer your question, Ryan. I don't remember the syntax, but we do have the ability to go look at what is the firmware version. There's a whole list of things that firmware version. We can look at the version, the vendor, when the release date was. So we can actually go and grab that information for that. So you can go again using something like the diff tool, the survey tool. You can actually go and lump. Okay, I've got these BIOS versions out there, these BIOS versions, and that's probably in a lot of environments. It's going to be variable depending on when that hardware came into the data center or wherever. So we do have the ability to go determine that. As far as the workflow to update that, we have the ability to create a routine that would update that firmware. I personally haven't looked at what in regards to the Spectre Variant 2, what workflow that would be. But as again, going back to our roadmap to be able to provide remediation samples, that will be, that's when we'll delve down into the workflow to make sure that happens. So with orchestration routine to make sure this happens before that happens. And obviously you'd want to modify that to offload any kind of workload that those machines or those applications, if they're application servers, there's a whole series of that. But we do have the ability to go detect what BIOS is there for most, machines. We can actually, if they're bare metal, we can even go detect microcode that, like the Intel. All my stuff is, when I was playing with that, all my stuff is VM, so VMware doesn't really put a lot of that stuff out, but we do have the ability. Great question. Any other questions out there? Either about vulnerabilities in general, Spectre Meltdown, or any Salt or SaltStack Enterprise. I'm opening it up to anything. Anybody I'm assuming since we haven't heard from the grand voice that no one from online. Any questions from online?
There's a couple online.
All right.
Is there a way to target using grains for the survey runners? I don't see anything in the doc.
Yes, it's just same targeting. You'd use the same targeting. I chose globular expressions. I could have easily chose a grain value there.
Okay, we have one more. Although Spectre is important, can you mention other threat remediation like Wanamine?
So again, the methodologies are going to be, I didn't come prepared to talk about other specific vulnerabilities. But the remediation is going to be very similar. And like I said, the vast majority of your current vulnerabilities that we know about are going to be taken care of by our Windows agent or the package module, where it's going to go out to and look at what what security patches on Windows, for example, are available. It's coming from Microsoft, and then any kind of CVEs that are available from there. And that's one where I'll give Hubble a huge plug. With Hubble built into Hubble, whether it's the Adobe open source version or which is essentially all we did was just make it available through Enterprise and kind of turnkey the system for you. Using that Hubble tool to do live CVE scans. So if in the CVE perspective, if vulners.com knows about the vulnerability, well, we can then use that information to create using the package.upgrade and go update that package with the latest version. And then when Microsoft releases its known vulnerabilities, our update agent module will detect that. So great questions. Thanks. I'll just go ahead and end. Thanks for coming, guys, and look forward to seeing you next month.